got relatively simple equations. Simple meaning that the variable is already contained to one spot, right? And then all you really have to do is ask yourself what happens to that variable. In order, what happens? What happens? Times 3, my fault. Times 3 minus 5. Then divided by 11. Then plus 2. All right, this is what happens to the variable to make it equal negative 14. H times 3 minus 5 divided by 11 plus 2. And then we're going to undo those things in reverse order. So subtract 2, multiply by 11, add 5, divide by 3. All right, that should be the order to undo what's been done to H. So minus 2 and plus 2 will cancel out. Minus 2 on this side keeps balance in the equation. We got 3h's minus 5 on 11 equals negative 16. Then times 11, we'll get rid of a divide by 11. Times 11 over here, we'll keep the balance in the equation. So we got 3h's minus 5 equals 160 plus 16 more, 176, negative 176. Then add 5 to get rid of a minus 5. Add 5 over here to keep balance. 3h's equals negative 171. Last move, divide by 3. All right. Divide by 3 takes care of times 3. On the other side, divide by 3 to keep balance. H. My fault. H equals negative 57. You can grab a calculator, double check your answer. You're going to do all of this, replace H with negative 57, see if the answer comes out as 14. So we got understood parentheses. So parenthesis, 3 times negative 57 minus 5, close parenthesis, divide by 11, plus 2, enter. Okay, negative 14. So we know we're good. Sometimes we can run into problems when we've got a complicated equation. There's 2 different problems that we can run into. So I'm going to show you how that works. Simplifying everything on the left of this equation, we've got distribute by 4. 4 divides each term in the numerator. So 2 divided by 4 is 1/2. Plus 6 divided by 4 is 1.5, so 1.5 W's. That subtract 1W. Combine my like terms, we got 1/2 plus 1.5 minus 1 is 1/2 W. All right, all of that equals, simplifying this, we got 3 plus 1/2 W. Here's going to be my issue. I got 1/2 W over here. I got 1/2 W over there. When I subtract 1/2 W from each side, so minus 1/2 W's, minus 1/2 W's, I'm not going to have anything left. My variable terms are going to disappear, and I'm going to get a wrong answer. 1/2 equals 3, which is not true. So if that happens to you while you're solving an equation, all the variables drop out and you end up with an untrue statement at the end, then you have to say that this entire equation is wrong. is not a true equation. Or you could say no solution. No real number solves that. The other thing that can happen if you've got variables in multiple locations is this. The left side is simplified as far as it can get simplified. I'm going to simplify the right side. 4 multiplies each of the terms. I'll distribute the 4. So we got 8y minus 20. That plus 22. Combine like terms. 8y plus 2. And that is equal to 8y plus 2. All right, I got the same thing on both sides. What's going to happen when I subtract out that 8y is, again, my variable term disappears from both sides, but this time I get a true equation. 2 equals 2. So what that's going to mean is that every real number will solve this. No matter what I put in for y, it's going to make the equation true. So the solution here is all real numbers. Your science teachers are going to love you if you can handle these. Solving literal equations, basically what it means is you're given a formula of some sort. There's more than one variable. Right now, this equation is solved for A. A is the thing that's by itself, and you're asked to solve for a different variable. So you use your opposite operations and your number properties to isolate one of the other variables. In this case, we're being asked to solve for C. So the question becomes, it's same as if I had numbers in here, as if the B and the H and the A were numbers. What is happening to C? So this is what's happening to C. First I'm adding B. Then I'm multiplying by 1/2. Then I'm multiplying by H. Okay? And we're going to undo those things in the opposite order. So divide by H. Divide by 1/2, which is the same as multiply by 2. And then subtract B. All right? If I do that, this is what happens. All right? Divide by H on both sides. I can't simplify this, so it's just A over H equals all this. Multiply by 2 on both sides. Again, I can't really simplify anything. I can put these next to each other. 2A over H equals 1/2 times 2 is just 1. B plus C. And then finally subtract B from both sides. All right. I'm not going to be able to combine any of this. B minus B will cancel out, and we've got C equal to 2A's over H minus B. Okay, so you don't get a final answer when you have a lot of variables in the equation. All you're really doing is writing a new formula solved for a different variable. Same kind of thing. See another example. Mass equals force divided by acceleration is currently solved for m. If I want to rearrange things to solve for F, I need to get rid of a divide by A. So I'll multiply both sides by A. We end up with m times A equals F. All right, nice and easy. If instead I had wanted to solve for A, I could just go one step farther, divide both sides by m. Times m, divide by m, cancel out. A equals force over mass. All right, so that's rearranging formulas, also called solving literal equations. Then we got the best kind of problem. Jazz has a stack of 6 cookies on the lunchroom table. That stack is 12 millimeters higher than it would be if he ate 2 and put the rest on his plate, which is 7 millimeters thick. How tall is 1 cookie? All right, math doesn't usually come at you in the world in a nice clean equation. Usually it comes at you as a mess. You're not usually calculating with cookies, but this is the idea. All right, so let me draw a picture. Jazz has a stack of 6 cookies. Get a feel for this situation. That stack is 12 millimeters higher than it would be if he ate 2 and put the rest on his plate. So ate 2, put the rest on his plate. That's 4 cookies left on top of the plate. The plate is 7 millimeters thick. And back to the beginning, 6 cookies is 12 millimeters taller than this other stack. Question, what's the width of 1 cookie? So we'll call that W. And I try to build an equation out of that. All right, so we've got 6 W's minus 12 millimeters will be the same height as 4 W's plus 7 millimeters. All right, set up an equation. Add 12 to both sides. Subtract 4 W's from both sides. Two W's equals 19. Split that in half. W equals 9.5, 9.5. All right, so 1 cookie is 9.5